Okay, first thing I want you to do is open up your note packet, which is the blue one. There's a blank white paper in the front, so I want you to open that up to the very front white blank paper. At the top of that, I want you to title it Simplifying Radicals, please. So at the top of the blank white paper, I want you to title it Simplifying Radicals. The ninth grade teachers, we kind of changed our minds a little bit in regards to how we're going to do this. Mara, are you sure you can see okay? Okay. We're going to start today with simplifying two radicals together, okay? As a short review from the Gold Packet videos, I'm then going to introduce the next chapter. We're going to start the notes, not get very far, but start it. And then you're going to have 8 problems like these for homework tonight, but it shouldn't take you very long. I'm going to collect them on Monday so I can see how each of you are doing, and I can assess how much time I really need to spend reviewing with you on it instead of just starting it all today, because you guys might really not need a long review. Quiz on those won't be for a while, so no quizzes for a while in here. I'll keep you posted like I always do, okay, as early as I can tell you. All right, so number 1 on the white paper in your note packet. Before I even ask you how to do this, does anyone know the answer to number 1? If you watch the videos. 5 what? Good. Answer is 5x. Raise your hand if you knew that. You just didn't feel like answering. Awesome. Okay. All you have to do here, I'm going to explain, is when you're simplifying a radical, first thing is I would separate them. Separate your coefficient, separate your variable. So separate them into 2 separate radicals, square root houses, whatever you want to call them. And then if something's a perfect square, I usually have students just circle what the perfect squares are. 25 is a perfect square. The square root of 25 is 5. X squared is a perfect square. Does anyone know why, or how do you know if a variable is a perfect square? Mrs. Warnock said it on the video. Angela? If the exponent is, say that again. How do you know, though? How do you know if the exponent's a perfect square? 2 is not a perfect square. Do you know what I mean? So how do you know if the, good job. If this exponent is even, it's considered a perfect square. And to take the square root of this, all you do is divide that by 2. 2 divided by 2 is 1. So x to the first power is the square root of that. So that's how the answer is 5x. That's the easiest you'll see them, is like number 1. Okay, number 2, a little harder. First thing I always had you do if I were to teach this to you is separate them, square root of 27, and then square root of x to the 8th. 27 is not a perfect square, so we need to change this to the product of 2 integers. One of the integers needs to be a perfect square. So what can you change 27 to? Jake? 9 and 3. So if you change 27 to 9 times 3, 9 is a perfect square. Obviously 3 is not, but that's okay. Is x to the 8th a perfect square? It is, because it has an even numbered exponent. That's the easiest way for me to tell you this. When you guys take Algebra 2 in 2 years, I think it's chapter 6 in that book, they give you problems like this, but they're harder. So if you can use the shortcuts from this year and apply them and understand them, it'll help you a lot when you get to Algebra 2 in 2 years. Okay, so the next thing you'll do is circle the perfect squares. Square root of 9 is 3. And Kate, what's the square root of x to the 8th? Good job. And then you leave square root of 3 inside the radical, and that's your answer. And again, I know the video did a lot of these, just like a little review. Before we move on to the next chapter, does anyone have additional questions on this? Need something clarified on these 2 problems? This is just a warm-up. Yeah, I should have done it quicker, but I wanted to spend a little time explaining. You'll have 8 problems like these for homework tonight, so I just want to make sure you can at least do these 2. All right, we're okay? Okay, let's flip then. Flip to your next page in your packet. That's the start of the chapter. So again, this note packet is a combination of chapters 3 and 6. It's all about solving equations and inequalities and illustrating them on the number line. So we changed the book. The book separates 3 and 6. You guys have actually learned this before. You should have learned all this in 7th grade. So it's kind of like we're reviewing, but yes, I'm teaching it to you. But 3 and 6 are merged together, okay? And you'll see what I mean when we get to section 6.1. We're going to start this today, and then whatever we don't finish, we'll finish Monday. So our objective for this lesson is to solve equations and inequalities. 1-step, 2-step, and multi-step. This is much easier than factoring, than graphing parabolas, and than the probability chapter. Did you guys like the probability chapter? Some yes, some no. Just curious. Okay. It was like experimental, theoretical, compound events, factorials, permutations, combinations. Okay. Just wondering. All right. So first part of this lesson, we need to talk about what these symbols are and what they mean and what the graph looks like. So the first one, John, what is that? Good. That's an equals symbol. So equals to. And before I pull this down, does anyone know what the number line or graph looks like if it's equals to? If you have a graph that's like this, and I say to you, the answer of an equation is x equals 3. What would the number line look like? How would you illustrate x equals 3 on a line that goes this way? Jake? Yeah? And then what? Okay, Chase? Actually, good job. That's for the coordinate plane. We're getting to that. You're ahead of us. Just on a line that goes this way. Yeah, just a dot. So equals to is just a point above what it's equal to. That's it. Now Chase is right, when we get to a coordinate plane, it's going to be a vertical line. And I'll explain that more when we get to it. Okay, what's the second symbol? Anyone know? Angela? Good, not equal to. And if something's not equal to something, on your number line, you're going to have an open circle on what it's not equal to, and it's going in both directions. So if I said to you, x does not equal 4, there's an open circle on 4 because it cannot equal 4. So that open circle illustrates not equal to. The arrow's going in both directions, not equal to. Open circle, going in both directions. You'll always see an equal sign with a line through it. All right, Jess, what's the next symbol? Good, greater than. Does anyone know what would that number line look like? If it's greater than. Okay, do you have an open or closed circle? If I said x is greater than 4. Nope. Anyone know why it's open? Why would it be an open circle? Angela? Good, it's not equal. So if it's x is greater than 4, or in this example, x is greater than -1, it can't be equal to that number. On this one, it cannot be equal to -1. That open circle tells you it can't be that, but it can be anything where this arrow is. So greater than -1 or greater than whatever it might be, has to be greater than that. If I said you guys are all greater than 6 years old, no one in here is 6 years old. If I said all of you are greater than 12, none of you are 12. John, are you 12? That's why I said you're all greater than 12, which means you're all above 12, including me, right? We're all above 12. Okay, anyways, open circle. The second one is less than. Less than also has an open circle. If I said x is less than -3, it can't be -3. It has to be less than that. So x is less than -3. Can't be equal to that. It's less than. Your arrow is going to the left because it's less than. It's always going to the left. Greater than is always going to the right. Okay, Celine, what's the next one? Good. Greater than or equal to? If it's greater than or equal to, I'll say all of you are greater than or equal to 14 years old. Is that a true statement? Yeah. You're all greater than or equal to 14 years old, right? Who's still 14? Raise your hand. Okay. Oh, about half of you. Okay. So we're all greater than or equal to 14 years old. You would have a filled in circle because some of you are still 14. Arrow going to the right. My arrow needs to go further, right? Some of you are 15. No one has their permit yet. Is anyone 16? Okay, I didn't know that. Kate's 16. So filled in circle represents all of us, right? It's going to the right because we're all older than that. And then the last one here is less than or equal to. And let me move this down for you. Less than or equal to is still a filled in circle. Okay. You know, you could say your algebra book is less than or equal to 8 years old, which is true. Filled in circle on what it could be equal to and then what it's less than. So less than or equal to, filled in circle, arrow going to the left. Okay, you should have seen all of those symbols before. Does anyone have a question on any of those? Okay, the next little box below, I want you to try that on your own. And I want you, if it's true, to put a T. If it's false, I want you to put an F, if you didn't already do it. So that little box below, if it's true, put a T. If it's false, put an F. If you need to use your calculator, go ahead. All right, Janelle, what'd you get for number 1? Good. Andrew, number 2? Good. Carly, number 3? Good. Daniela, number 4? Good. Jess, the 5th one? Is -10 greater than -4? Good. False. Brandon, the second to last one? Good. Amber, the last one? Good job. First 4 are true, the last 3 are false. Any questions on that one, on that part? Okay, flip over. Flip over. No, at the bottom, sorry, at the bottom. There's 2 rows now. We're jumping around a little bit. There's 2 rows for inequalities. So here's the first one. You should already know these. First one says from your book, from chapter 6, when you're multiplying or dividing both sides of an inequality by the same positive number, the inequality sign stays the same. When you're multiplying or dividing both sides of an inequality by the same positive number, the inequality sign stays the same. Nothing's changing. So if that's true, what's going to happen if you multiply or divide, like this one on the board, both sides by a negative number? What happens to this sign? Does anyone remember from 2 years ago? Liz? Yeah, it switches. It's flipped or reversed. So when you're multiplying or dividing both sides of an inequality by the same negative number, the inequality sign reverses or it's flipped. So it reverses or it's flipped. However you want to say it. I say flipped a lot. So it means it would actually flip around. Only if you multiply or divide both sides of an inequality by a negative. It's the only case that happens. Questions on those roles? Okay, let's just do the next page and then we'll stop for today. So flip over to the next page. There's some things you have to fill in and that I need to explain. What? I know. Thank you. I just want to finish this. Give me a minute. Thank you, guys. Okay, so just give me a minute. So what I want you to fill in here is graphing solutions to inequations. It says here, when solving for one equation, we are only solving for one variable, that being the x variable. So we're only solving for one variable, which is the x variable. And then it says here, since we are only solving for the x variable, we will only use the x-axis. And I kind of said this before, the x-axis is a horizontal line, so it's going to be going straight across. And you'll always illustrate what x equals on your x-axis with a dot. So you'll also fill in the word dot. And then the example's already drawn for you. Okay, and we talked through this, but just so you have it written down. Okay, and then one more thing. If there's 2 axes, Chase actually already told us this, when graphing solutions with both the x and the y axes, the graph is going to be a straight or vertical line through the answer. So for example, the one up there, I think it's x equals 4, but even if it's 5, that's okay. X equals a number, you always put the point on the x-axis where that number is, and then you draw a vertical line going straight through it. Okay, any questions so far? All right, I want you guys to put your name on this. Those notes we're going to finish Monday. You don't have homework on that yet because we need to finish it first. Well, you do. It's this little tiny piece of paper. Okay, there's 8 problems on here. This is your homework. So I want you to get started on this. You need to simplify the radicals completely. And then those of you that did not show me your gold packets, I need you to take that out now so I can come around and check that. So that little piece of paper is your only homework.